Hi, welcome to the video. So today we'll be looking at the 1996A, the Lex problem from codeforces. So the question goes something like this. So we have a farmer named John. So he counted the legs of all the animals which are present in his farm, and only chickens and cows live on the particular farm. So the cows will have four legs and a chicken has two legs. So we have counted the total number of legs that are present in the farm. So we have to output the minimum number of animals that are present in the farm based on the given number of legs. So the approach, let us look at the approach we'll be taking here. So I'm taking the example input options. So if we are given that the number of legs are 2, so basically this is the formula for counting the number of animals on the farm. So I'm taking A as the number of cows that are present and B as the number of chicken that are present in the farm. So the number of legs will be equal to 4 times for each cow, right? 4 into number of cows plus 2 legs for each chicken, so 2 into number of chicken. So this sum of this will become the total number of legs, right? So the given legs ka count should be equal to this formula, right? So at the same time we have to find the minimum of such combinations, right? So for the given 2, right, what are the possible combinations of A and B? A can be 0 and B can be 1. Thus 4 into 0 is 0 plus 2 into 1, which is 2. So the total will be 2, which is equal to the number of given number of legs. And since only this is possible, because if we say 1 cow is present, then 4 into 1 will become 4, which is already greater than the given number of legs, right? So no other possibility is here. So this is the only possible answer, and the sum of A and B is 1, which is the output. Okay, let us take another example where we are given that the total number of legs counted is 6, right? This 6 should be equal to 4A plus 2B, where A represents number of cows, B represents number of chicken, right? 4 legs for each cow and 2 legs for each chicken. So 4 times A plus 2 times B should be equal to the total number of legs that are counted, which is equal to 6. So as you can see, there are two different combinations possible. A can be 1 and B can be 1. 4 into 1 4 and 2 into 1 2. 4 plus 2 is equal to 6, which is the given number of legs. Or A can be 0 and B can be 3, right? 2 into 3 is 6 and plus 0, so total is 6. Similarly, we are getting 6 legs in both the cases, right? So of these two cases, the sum of A and B is 2 here and sum of A and B is 3 here, right? So we are to output this value, right? Minimum sum of animals, right? So similarly, if we take 8 legs, then there are 3 combinations possible. A can be 0, A can be 1 and A can be 2, right? If you take A as 0, B will become automatically 4, right? 2 times 4 is 8, which matches the input number of legs. If you take A as 1, then B will become 2, right? 4 ones are 4 and 4 is remaining out of this 8. So 2 times 2 will become 4, right? That will match the total number of legs. Similarly, if you take A as 2, total number of cows as 2, 4 times 2 is 8. So we have filled the, we have considered all the legs in the farm. So no chickens are present, right? So these are the 3 combinations which are possible. For each combination, you can see the summation of number of cows and chicken here. For the first case, it is 3. For the second case, it is 2. For the third case, it is 4. Right? So we have to output the minimum number of animals which is possible. So if you see, we are to minimize the number of animals for a given number of legs, right? So we are to consider as many cows which has the maximum number of legs in the given combination, which is 4. To We have to use the cows to fill as many you know we are to consider maximum possible cows in the group, right? So that you cover for each cow, for each animal, you cover 4 legs for each cow, right? If you take chicken, then for each chicken you are covering only 2 legs, so the number will be larger. So we try to fill the total number of animals with cows first, and whatever legs is left out, we try to fill that with the chicken. That is how we will arrive at the minimum number of animals possible, right? So that is the logic written down here. This is the first approach. Let me just write it down. This is approach 2. I'll come to that later. So here what are we doing? We are dividing the given number by 4. This gives the number of cows that are possible, maximum number of cows that are possible, right? The quotient gives the number of cows that is there. Then whatever is remaining, right, the remainder, we take that and you know uh, divide by 2 and take the quotient. This is the number of chicken that are present, right? So we can just output the sum of A and B here. So the formula looks something like this. We try to divide the number of legs amongst cows. Whatever legs were remaining, we try to divide it among the chicken, right? That is one approach. You can just iterate through the input variable and just try to figure out the value and print this out. That is one way. And even better approach is, if you have observed something here, you since the number of legs for chicken is 2 and number of legs for cow is 4, and we are trying to max out the cows ka count, so you can either have 0 chicken or 1 chicken, right? Because the given input can either be divisible by 4 or is divisible by only 2 and not 4, right? It can either be 8, which is divisible by 4, or it can be a number like 6, which is not divisible by 4 but still an even number, right? So in the first case, where the number is of the representation 4n, in that case we don't have any chicken, right? Similarly, in the other case where we do have the number representation of 4n plus 2, right? In that case we have 1 chicken. So what we have to find out is just divide the number by 4. That gives you the number of cows present in the farm, and after that you just need to check if the given number is divisible by 4 or not, right? If it is divisible by 4, then we have covered all the legs given by using only the cows, right? Otherwise there is one pair of legs which was left after covering the number of legs using the cows, and then that is covered by 1 chicken, so we just have to add 1 after that, right? This is the second approach, right? A little more optimized approach. Both of these will work fine, should not be an issue. So that is the we'll be following the second approach in the solution, right? So I hope it is clear till now. Moving forward, so this is the code. This is all basic boilerplate. So this is the formula I'm using. We just divide the input given by 4, and then we add 1 if the number is not divisible by 4. Otherwise we leave it as is, right? So let us wait for a minute. it's taking longer than expected, not sure, but that is the approach. I might even cut the video by now, but not sure why it is taking longer. Yeah, that's the approach, guys. So I'll upload a screenshot of the success at the end. So thank you for watching the video, and see you in the next video. Bye.